Okay, hello there, and today I'm going to be working through a vectors question from the Edexcel Mechanics 1 paper from January 2011, and this is question 4. So I'm going to work through the question one part at a time and explain to you how the mark scheme allocates the marks at each point. So, a particle P of mass 2 kilograms is moving under the action of a constant force F. So we're told that it's 2 kilograms and it's being acted on by a force, and the velocity of P is 2I minus 5j at time t equals 0, so that's when it starts. And then 5 seconds later, when time is 5, it has velocity 7I plus 10j. And to start with, we have to find the speed of P at t equals 0. Now the velocity of P at t equals 0 is 2I minus 5j. So what we're going to have to do to find the speed at t equals 0, that's going to be the magnitude of this vector. So if the velocity is 2I minus 5j, that is going to be the magnitude of this vector. And to find that, we're going to do 2 squared plus 5 squared, and we're going to square root it. And that will give you, if you were to leave it as a surd, it would be square root 29. Or if you were to actually work that out with your calculator and round it, it would be 5.39 meters per second. And that's the speed of the particle P at time t equals 0. Now, where the marks here are allocated, you get one method mark for knowing how to find the magnitude of the velocity and knowing that that is indeed the speed, and you get an accuracy mark for your correct answer. So that's how the 2 marks are allocated. Okay, so moving on, for part B it says find the vector f in the form a times I plus b times j. Now whenever you see a vectors question involving a force, you should be thinking about the formula F is mass times acceleration. This is a fully transferable equation to a vector setting. Now, we are told that the mass of the particle is 2 kilograms, but we don't know the acceleration. So before we can find this vector F, we have to find the vector for the acceleration. Now, F equals ma is one formula that you will have seen before and can be written in vector notation. Another one, which also involves the acceleration, is v equals u plus at. So that's one of the Suva equations, and that can be used as well using vectors. Now we know that when time is 5, the velocity is 7I plus 10j, and when time is 0, the velocity is 2I minus 5j. So what I'm going to do is I'm going to set this as my value of u, my initial velocity, this is my final velocity v, and I'm going to substitute the value of 5 for t. I'm going to do all of that into this equation. So the velocity, or the final velocity, is 7I plus 10j, and that is equal to the initial velocity, which I was given to us as 2I minus 5j, and the time was t equals 5, so plus 5 times the vector for acceleration. Now if I was to put these two terms on the left hand side and rearrange, I would get that 5I plus 15j is equal to 5 times the acceleration. So dividing both sides by 5 tells me that the acceleration vector is I plus 3j. And now that we've found this acceleration, we can find a vector for the force using F equals ma, because F is just mass, which is 2, times the acceleration. So the vector was I plus 3j. And expanding this bracket gives me 2I plus 6j newtons. Now that's the final answer, that's the vector, it's in the form a times I plus b times j. Just to give you an idea of where the marks are allocated on this question, you get 1 mark for correctly substituting values of v, u and t into this equation, so you get 1 method mark. And you also get 1 accuracy mark for this, doing it correctly. So knowing that you can set the initial velocity at time t equals 0 as u, and the velocity at time t equals 5 as v. Now, successfully rearranging this to get a vector value for the acceleration, that is another accuracy mark, and then substituting this expression for the acceleration into f equals ma, that's a second method mark, and the final answer gives you another accuracy mark. And one thing to note is these 2 marks at the end, for substituting the acceleration into the force, they are follow-through marks. So even if you were to get the incorrect answer here, you could still get some credit by correctly substituting your value for acceleration into the formula f equals ma. Looking at part C of this question, the question asks us, find the value of t when p is moving parallel to I. So what I'm going to do is I'm going to use the same formula again. V is u plus at. And what this can be used is, this can be used to write a general vector for the velocity of p at any given time. So it depends on time. And whatever value, if time changes, then obviously the velocity changes. So as before, the u is the initial velocity. So time at t equals 0. So that's 2I minus 5j. And I worked out in the previous question that the acceleration was I plus 3j. So I'm going to add time times I plus 3j. Now notice I haven't substituted a specific value of time here. This is a general expression for the velocity at any given time. Now when this is the velocity of the particle p, when p is moving parallel to I, then this vector, this velocity, must be equal to some constant, which I'm going to say lambda, times I. So in other words, the j component of this vector is equal to 0. Because if there is any j component, then the particle will be moving slightly up or down as well as along, and it therefore wouldn't be parallel to I. So it has to be equal to some constant times I, and that is essentially us saying that it can't have any upward or downward movement, so j is equal to 0. And what I can do here is, if I know that the j components are equal to 0, then this minus 5j plus 3tj, they must cancel each other out. So I'm just going to make this nice and clear what I'm doing. What I am doing is I am equating the j components of the vectors. So if I was to say minus 5 plus t times 3, so plus 3t, that must be equal to 0 because it's parallel to I. And we can solve this now to find the value of time such that there is no j component to the velocity of p. So obviously putting the 5 on the other side tells me that 3t is equal to 5, so therefore t is 5 over 3 seconds. So in terms of where the marks are allocated here, you would get a method mark for writing this general expression for the velocity of p at any given time. Okay. Now, setting this equal to lambda I, or essentially knowing that the j parts of this vector must cancel out, that is a second method mark, and you get an accuracy mark for getting to this equation. And then solving this correctly to get your final answer of 5.3, that is your fourth mark for this question. Okay, so that was the January 2011 paper, Edexcel M1, and that was question 4 on vectors. So thanks ever so much for watching. Hope to see you again sometime soon.